Sweet. Okay, cool. So this evening I'm going to be talking about testing the new web. Before I do that, I have to apologize to Ben because I don't have a slide saying I'm really happy to be talking with him. But I am actually happy to be talking with him, so I apologize for that. So I also work at Oxbotica. I think Ben did a pretty good introduction to what we do, but I mostly work on web tooling around our data infrastructure. And what's pretty cool about working at Oxbotica and the web is that we get to work on lots of new web APIs. And as someone that's interested in testing, that means there's lots of interesting challenges around how we test some of these projects that we're using new web APIs in. But as someone interested in testing, the thing that kind of always shocks me is that the web has moved pretty fast, even in my lifetime. So I think Ben's already showed this exact screenshot already, which is lucky. But this is the first web browser built by Tim Berners-Lee, and this is what the web looked like on the day I was born, just about kind of rendered text and images in a pretty simple browser. And then if we jump to this year, 2020, these are the best stock images I could find to represent the web in 2020. We've got VR, touchscreens, kind of full-on immersive 3D games. And if you wanted to go kind of down the audio route, you can build full-on DJ apps and whatever you want using the web nowadays. But how does that compare to the world of testing? Well, in '93, as far as I could tell, there was no testing on the web. I'm not sure that's hugely surprising, given I think it just kind of rendered static content at that point. But at the same time as the first browser, we didn't really have any notion of testing on the web. The first time we see some testing appear was probably about the same time that kind of JavaScript itself appeared in 2001, when JSUnit was released. And what you might notice from the sample code here is that it's pretty similar to the test we write 20 years later. We have a setup function, a teardown function, and then in our test we assert two variables that equal. So not too much has changed since 2001. The next big jump in the world of testing came in 2004 when Selenium was released. And this was the first time we as kind of web developers and testers on the web could actually interact with the browser. So we could click on buttons in the browser as a user would, rather than just testing little bits of JavaScript. So that was pretty cool. Then in 2008, along with jQuery came the testing framework QUnit. As you can see, even though it's 7 years later than JSUnit, we still have the same kind of structure to our tests. And I believe if you use Ember.js as a framework nowadays, this is still the framework you'd use for testing that, even though it's kind of 12 years old. With Jasmine, this was released by the team who worked on JSUnit. Again, the tests look pretty similar. And this has also stood the test of time, being the test framework you use if you work with Angular nowadays as well, which is just pretty cool. In 2014, Facebook released their kind of take on unit testing in JavaScript with Jest. Again, the tests look pretty similar to 2001, although they did add the new kind of model of snapshot testing. And for those who haven't had a chance to use Jest for testing JavaScript, snapshot testing is the idea that we take snapshots of our components, the kind of the DOM output, and store them in a file next to our tests. When we run those tests again, we take a new snapshot of the DOM and compare the two, and it will kind of tell you if there's a diff between the two snapshots. Kind of the aim being you don't have to check every single value in your component, you can just render the whole thing and double check it. So it's pretty cool to have something a bit new in the world of testing. And then the last few years, we've kind of seen an influx of new browser automation frameworks. Selenium, for those who might not have heard of it, is pretty heavy. It's written in Java. You can use different languages now, but it's a pretty heavy thing. You have to kind of deploy different Selenium runners everywhere, and it's pretty heavy duty. So a lot of people have been trying to make it simpler. So in 2014, Cypress was released. In 2015, Test Cafe was released. And in 2017, the Chrome team released Puppeteer, which is a Node.js tool for automating the Chrome browser, which is pretty cool. So is it fair then to say that not much has changed in the world of testing in about 20 years? And I think to kind of work this out, we can look back at what people used to say about testing the web back in 2005. So a guy called Mark Daggett wrote a book called Expert JavaScript. In that book, he described the 4 reasons why testing the web was impractical. And the 4 reasons were, first of all, around tooling, that JavaScript community doesn't have the same quality of tools as other languages. Secondly, around user interaction, that most of us, when we're building our websites, we need to test them by kind of simulating human interaction, and that's quite difficult. Thirdly, debugging. In 2005, there was no way to step through your tests using a debugger. And finally, the host environment. So obviously on the web, we have the problem of lots of different browsers, all with different features. And obviously this makes testing things a little bit difficult. So we can kind of go through these and see how we've improved in the last 15 years. So first of all, around tooling, I think it's fair to say that the JavaScript community has just as good, as if not better tools than other languages around testing. So I think it's fair to say we've kind of nailed this one. Second of all, that JavaScript is intrinsically linked to the user interface and must be tested by a human. This is still pretty difficult. Like, it's still quite hard to simulate testing our websites exactly the way a user would. but we have lots of browser automation frameworks now which let us test web apps in all sorts of different ways. So we can get pretty close to this. So I think we can tick this one as done since 2005. Thirdly, that there's no way to step through a test with a debugger like other languages. This is something that has kind of come into prominence in the last few years. There's debuggers built into VS Code, built into WebStorm. And if you run your tests in the browser, like for example, using Jasmine's test runner, you can use the debugger that's built into the browser as well. So we've got that one. And finally, that testing is impractical because of the ever-changing environment browsers. I think this one, if anything, has probably got worse in the last 15 years rather than better. You can kind of run the web on a calculator, Nintendo Switch, PlayStation, whatever you want to these days. So this has probably got harder since 2005 rather than easier. But in 2020, I'd probably add one more thing to this list, and I'd add that it's becoming increasingly difficult to write tests that give us a high confidence in our web apps as the depth and breadth of the web platform increases. And what I mean by this is a lot of the APIs that come into the web nowadays change the way we interact with the web. We just saw in Ben's talk that we can now talk between two browsers rather than to a web server. We have things like VR and the web audio API. And if we were building like a DJing app, we can't have a bunch of robots spinning decks in the office to test it. That's impractical. And if we can't actually simulate the way our users are going to use our apps, then it's quite difficult for us to have as much confidence in our apps as we used to with more traditional web applications. So to see how this is a problem and how we can solve it, we're going to build a startup together in this talk. And the startup is Bubble Wrapper. Obviously, being a startup, you have to delete some letters from the real world and add an R on the end. So this is Bubble Wrapper. And it's just a simple app, kind of popping bubble wrap. And I think that's the kind of thing we could all do with at the moment. And what we're going to do is we're going to go through and add increasingly kind of complex and interactive features to it and see where we have difficulties testing it and then how we can overcome them. So first of all, we'll start by making it a mobile app. Second of all, we'll make it peer-to-peer bubble wrapping so we can kind of pop bubbles with our friends. Thirdly, we'll do it in 3D so it's a bit more immersive. And then finally, we'll make it truly immersive by making a virtual reality bubble wrap popping app and seeing how we can test that kind of thing. So first of all, let's start with our first testing challenge, which is testing web apps on mobile devices. So let's have a quick look at how our app looks on a mobile device. So hopefully you can see my mobile screen there on the right. It's a pretty simple app. We have a bunch of bubbles on the screen and we can click them and pop them. And what you probably can't see, but I can feel in my hand, is that this uses the vibration API that's built into the browser. And this just kind of gives me a bit of feedback when I pop the bubbles as if I've kind of popped a real piece of bubble wrap. So that's our app. It's pretty simple and it works like that. But what's the testing challenge here? Well, most end-to-end frameworks do not go further than emulating a mobile device by using a small screen size and a throttled CPU. And the frameworks that do have support for mobile testing are often limited in what they can do. And it might be the case that, if you're just building a responsive app, why does it matter? Why do you need to go further than emulating a small screen size? Well, the reason I think it's worth going further than that is for this reason. So these are the tables taken from caniuse.com, which kind of show the differences between browsers on different platforms. So on the left of the table, we've got Chrome on the desktop. In the middle, we've got Safari and Chrome on iOS, and on the right, we've got Chrome on Android. And what you can see from these is even when all these browsers support the same API, they often do it in different ways and implement things differently. So if you really want to have confidence that your app is going to behave the way you expect on a mobile, you kind of want to test it the way your users are actually going to use it rather than kind of in a virtual version of it. So what kind of support for that do we have in our testing frameworks? Well, in Cypress and Puppeteer, we can emulate that. So it'll let us run tests with a small screen size. And I think Puppeteer lets you slow down the CPU and slow down the network speed, which is pretty cool. With Selenium, you can run tests on mobile with additional tooling. So there's a project called Appium, which lets you run tests on Chrome on Android, Safari on iOS, and still Internet Explorer on Windows Mobile, which is pretty nice. But obviously the problem with this is that you have to write extra tests on top of your tests for desktop and run it in a separate tooling, which isn't kind of the most ideal thing in the world. So how can we solve this? Well, to solve this, we can use the end-to-end test framework Test Cafe. Test Cafe allows us to run tests on real mobile devices. So first of all, we can see what this test looks like. So it's a pretty simple test, and this would work on desktop and mobile. So first of all, we just navigate to the URL where our demo is hosted. Then we just check the number of bubbles are rendered on the screen and that none of them are popped. We then click 5 of those bubbles and then just double check that 5 of those bubbles have been popped at the end. So this is probably a bit of a simple test to really be written as an end-to-end test, but hopefully it's a good demo for writing mobile tests with Test Cafe. So how can we then test this on a mobile device? Well, Test Cafe offers this thing called remote tests. And what this means is that we can run these tests on any device we want. It will give us a URL we can navigate to, and then whichever device you want to test it on, you can navigate to that and it will run the test on that platform. And what's really cool about this is it has really, really good browser support. So I was able to run this on Chrome, Edge, Opera, and Brave on Android. And I know it works on Chrome and Safari and iOS, but I don't have a device to kind of check any more of the browsers on iOS. And what's even cooler is if you don't have one of these devices, it also supports browser stacks. So you can run it on kind of any device you could possibly think of remotely as well, which is pretty cool. So let's have a look at what this looks like. So as you can see, it's generated a QR code for me here, which I can then scan with my phone. What that'll do is then navigate to a URL on my phone, which will then run the tests on the phone rather than the computer. So that's Test Cafe connecting from my phone to the desktop where the tests are running. What it should do then is it should navigate to the site that we're testing, which is our bubble wrapping app, and it should run the tests we just saw. So it's just loading the bubble wrapping app now. Cool. So it's going to navigate around the page, click on those 5 buttons, and then double check they're popping. And one of the nice things about Test Cafe is if some of the elements are off the page, like that bubble there, it will scroll to find it rather than failing your test that you might find happening in other test frameworks. So that's run the test on my mobile device and then reported the results back to me here, which is quite cool. So that's pretty cool. We can actually test our mobile app on a real mobile device. And like I say, it's got huge browser support. So this is pretty cool. I think we can probably solve this one. It's a little bit manual. I've got to have the device in my hand, scan the QR code, enter the URL. So there's a little bit more automation that could happen there. But that's totally something that you could automate if you're really interested in doing it. So now we've got our bubble wrap popping on mobile. We want to make it peer-to-peer so we can kind of pop bubble wrapping together rather than doing it on our own. And I guess we can kind of use the technology we saw in Ben's talk to do that. So if any of you want to navigate to prpc.me/bubble-demo, you should see a kind of page of bubbles appear, or you'll see a bunch of buttons you can click, hopefully. Cool. So what you should be able to do is kind of press those buttons. Hopefully you'll feel a vibration if you allow the permissions. And then what it'll do is it'll pop the bubbles on the host device in the way we saw with the demos in Ben's talk. Cool. So what's the testing challenge with peer-to-peer content? Well, the problem is that usually when we're doing end-to-end testing, we're used to spinning up or using a deployed version of our web service. And then what we do is we test how our app behaves in a single browser. So we'll open a single instance of Chrome or Firefox or whatever browser we want. We'll click around in that application. That app will normally send requests to a server, render some new data, and we'll kind of check the data renders correctly. The problem is here, we don't have a web server other than that initial connection. So how can we actually test this with multiple browser windows? So one way I found to do this was using Puppeteer. So like I mentioned earlier, Puppeteer is a tool released by the Chrome team, which lets you kind of automate Chrome using Node.js. And one of the nice things about Puppeteer, unlike some of these other frameworks, is you can spin up as many Chrome browsers as your heart desires. So in this case, we could just spin up 2 of these browsers and use one to pop bubbles and one to host the bubbles, and then see that it pops the bubbles in one and it appears in the other window. So the code for that looks a bit like this. It's probably not the cleanest test I've ever written, but I think it does work for testing peer-to-peer applications. So first of all, we start it by creating the host browser. So this will create an instance of Chrome. It'll navigate to a window to host the bubble popping room. Then we create the client browser, which will then navigate to that hosted room. We'll then click one of the bubbles and then check that in the host page that bubble has been popped, and then it'll close down those 2 browsers. So we can have a look at what that looks like when it runs. So we're using Jest to run these tests in Puppeteer, but you can use whatever kind of testing framework you want. Puppeteer will work with anyone you can think of, so you can use whatever you're comfortable with. You don't have to use Jest to do this. So what we should see is it'll open the first Chrome window, and then it should navigate to host the bubble room. So it's generated a random test ID and navigated to a room with that ID on it. We'll then open a second Chrome window, and that should then navigate to that room. It will wait till it's made a peer-to-peer connection. Hopefully, it'll make a peer-to-peer connection. It apparently won't make a peer-to-peer connection, which is great. So I'll just show a quick video of this instead, because it didn't make a peer-to-peer connection. So I've got a quick video of this demo running here instead.
I take full responsibility for that. I'm sorry.
Thanks, Ben. I really appreciate that. So we'll see a video demo of that instead. So we'll skip forward to the first browser window opening. So yeah, like I say, this will open the bubbles demo in one window. It'll then hopefully spin up a second Chrome window where in the video it does make a peer-to-peer connection. It clicks the bubble in the first one and we see it happen in the second window, and then it'll close both those browsers down and our test will pass in the original window. So other than that kind of minor issue there, I think it's fair to say that we can probably test peer-to-peer kind of apps pretty well. So that's pretty cool. So now we can pop our bubbles peer-to-peer. We can pop them with each other. We want to make it a bit more immersive, make it feel like you're actually popping real bubbles rather than just kind of 2D things. So to do that, we want to make this a 3D app and use some of the new browser APIs for 3D content. So let's have a quick look at what bubble popping in 3D looks like. So I'm going to be honest, my ability with 3D modeling is not the best. So these are kind of the best bubbles I could come up with. So this is kind of the 3D app. You can move around and pop the bubbles as you move around in 3D. So I'm not sure if this is more or less immersive given how much this doesn't look like bubble wrap, but it's 3D, so that's still pretty cool. So what's the difficulty with testing 3D content? So the problem is that most 3D content on the web is rendered on the canvas. And what this means is there are no individual DOM elements rendered that we can access via traditional APIs when writing tests. You know, usually like the first two we've seen, we click on buttons, we kind of input text into input elements, and we can access kind of our web pages using that. When things are on the DOM, we can't actually do that anymore. So there are some ways of doing this. What you could do is add an API to your app that is only there when you run it in a test environment, and then you could send kind of events into the browser to trigger certain things to happen. That works okay, but obviously that's not the way a user would actually use your app. So it's kind of not truly a representative test of how your app will be used in real life. So it is quite difficult to test 3D apps, I think, at the moment. But there is one thing we can do to at least check that our apps are rendering correctly, and that's visual regression testing. So the way this works is as follows. Let's say that our original app, Bubble Wrapper, somebody wanted to change the name to Bristol.js. What they do is they kind of go and make that change the code, and they'd run the visual regression test. What would happen is it would take a screenshot of the new app and compare it to a screenshot of the previous one, and it would fail if there was too many differences between the image. So here you'd expect it to fail because the title is quite massively different in these two screenshots. And whilst this doesn't really let us test the behavior of the app, it at least kind of lets us test that things are rendering okay. So there's kind of a couple of ways we can implement this. Firstly, we could implement this ourselves from hand, and we can do this with the node module looksame. So this is kind of an open source tool for comparing images. So we're using Test Cafe here, but you could use any framework that takes screenshots. So we take a screenshot of the canvas element and we compare it to the expected version, which is the one where it was called Bubble Wrapper. And then we'll check that the result is equal. So this will compare if the two images are equal or not. So it's pretty simple. It's a pretty kind of easy way to just do a quick check that our 3D content is rendering correctly. So there are some pros to doing it ourselves. First of all, it's free, which is nice. Second of all, it's highly configurable. So the looksame module has loads of arguments we can use. So we can have thresholds for when it will fail the test. It will ignore like the flashing carry if you've got input boxes, and you can have all sorts of other configuration like that. And it's also pretty flexible. So if you want to take 60 screenshots in a test or whatever and compare them to 60 others, you could kind of totally do that in any way you want to, which is pretty nice as well. But there are some cons to this. There's like a ton of manual work to doing this. So let's say that you really wanted to rename the app Bristol.js. You'd have to go and delete the old screenshot that was the expected one, move the new one into the old one's place, and then run your test again to get a new result, which is kind of pretty impractical and would take longer than just booting up the app and kind of checking it yourself. And second of all, there's no diff visualization with this. So if your tests fail, you have to then go and run the app and check what's changed. There's no way of just having a quick look at what's changed between the two, which is going to add a lot of extra work when doing this. So we can automate a lot of this away, and we can do that with like a cloud-based visual regression tool. And in this case, I'm going to talk about Percy. So yeah, Percy's a cloud-based visual regression testing kind of software, and it's quite neat. It takes a lot of that work away from us and automates a lot of it for us. So the first benefit of using Percy is that the test becomes a lot smaller. So this is kind of the equivalent of that first test using Percy. So we just take a Percy snapshot. This will take a screenshot of the screen and upload it to the cloud platform and kind of do the comparison for us between those two images. And what it will do then is it will produce a diff that looks a bit like this between those two images, showing you the differences. And this makes it a little bit easier to actually make a quick comparison between the two and whether you actually want to accept the new changes or not. And we can have a quick look at what that looks like in Percy. So this is that visual regression test uploaded to the Percy kind of visual regression testing tool. And as you can see, it will show me the diff between those two images. And this is some of the powerful tools that it offers us. So it'll let us render it in Chrome and Firefox. And it'll also let you render it at different browser sizes. So this is quite useful if you want to test how your kind of web apps work responsibly as well. And this is the bit which lets us remove a lot of that manual work up here, the green thumb. This lets us approve this new image and say, this is the new expected image. This is what I want everything to be compared to from now on. So all of that work we had to do with the manual version can be automated for us using Percy, which is pretty neat. But there are some problems with visual regression testing you might have kind of spotted in that last image. If I showed you these two screenshots, you'd probably say these are exactly the same. And to a user using the app, they would be exactly the same. The problem is this would fail our visual regression tests for two reasons. First of all, there were some kind of moving pipes at the back of our screen, and these screenshots have been taken at slightly different intervals, so you can see those kind of pipes have moved between the two screenshots. And obviously that would fail these tests, even though it doesn't actually mean there's anything wrong with your application. But there's a slightly more subtler issue here. One of these screenshots has a different form of anti-aliasing on it, which means that the visual regression tests have picked up these slight pixel differences around the outlines of shapes in our 3D app. So whilst this does give us a little bit of confidence that things are rendered correctly, there's kind of a lot of manual work to do here. You've got to do a lot of verification. But if it's like really important to you to have your kind of 3D apps rendered correctly, this can be a nice way of automating away some of that manual testing just to check that things work correctly. So I'm not 100% sure we've kind of really got 3D testing right here, but we're going to move on to really making our bubble wrap popping immersive. And we're going to move on to doing bubble wrap popping in virtual reality. So let's have a little look at what that looks like. So what we've got here is our bubble wrap app before rendered in 3D. And what we've got in this kind of side panel here is the WebXR emulator. And this lets us kind of emulate as if we're wearing a VR kind of headset in the browser, but obviously without having to have one, which is quite cool. Let's kind of debug these experiences. So we can kind of move the headset around as if we were wearing it in real life. And we can do things like move the controllers around. And when they kind of, intersect with one of the bubbles, it will pop it. So I was really hoping to have a video of me kind of doing this with a headset, but I couldn't quite get it plugged in and working in time. So, this is kind of the best way we've got of kind of showing this working in VR at the moment. So what's the difficulty with testing VR apps? Well, most testing frameworks allow us to write tests to kind of click, drag, and type things on web pages. The problem is that in our VR applications, a viewport is controlled by a headset and interacted with using controllers. And these don't kind of use traditional browser events. We can't just interact with the browser in the way we usually would in our tests. We have to do things a bit differently here. And I spent kind of way longer on this than I'd like to admit. And the light bulb moment came, myself and Ben reached out to a member of the kind of W3C team working on WebXR. And they said that the closest thing they could think of for testing WebXR is the emulator extension. And then if you could find a way to drive that with Selenium or something similar, then you get pretty close to kind of end-to-end testing VR experiences. This is pretty cool. We just saw the emulator then. So I had a bit of a dig into the source code for this to try and understand how it actually works in the browser. So the way the WebXR emulator extension works is it injects a polyfill for WebXR into the browser. And what that polyfill allows you to do is post messages to it that actually control the view and also the controller position and things like buttons on the controllers and things like that. And the extension we just saw working there basically posts these messages back to your main Chrome window and lets you control that VR experience using a virtual controller and a virtual headset. And we can use the same approach to write tests for VR experiences. So there's kind of two ways we can do this. So we can use Test Cafe here again to do this. They have a functionality called client script. And what this lets you do is it lets you inject just JavaScript code into the browser you're testing. So we can inject that same WebXR polyfill into the browser. And then in our tests, we can dispatch those same events that get dispatched from the extension, which would let us kind of control the VR viewport and control the controllers and the buttons that get pressed from our tests and things like that. The alternative way of doing this is that, again, Test Cafe allows you to spin up different kind of instances of Chrome. And we could set up an instance of Chrome that had the WebXR extension installed, and then in the same way as our previous approach, post these same messages to the browser to control the VR experience. And I guess the benefit of this approach is that if the XR kind of emulator gets updated, you get those kind of updates automatically without having to kind of re-download the polyfill and install it yourself. And then once you've been able to control the viewport with our tests, we then have to decide how we can actually, test that it's working. So there's kind of two options here. If your VR experience, makes API calls when you click on things, you could test it traditionally and check those API endpoints have been called. Or in our case, when we're just kind of popping bubbles, you could use visual regression testing to take snapshots and all the bubbles have been popped to make sure that like the right numbers and right positions of bubbles have been popped after kind of the VR controls have moved about and things like that. So we can have a quick look at what kind of this actually looks like in practice. So we can run test VR. So like I say, what this will do is this will run a test cafe test here. It will spin up a Chrome browser. This is my browser that I've got WebXR emulator installed in, and then it will navigate to our VR demo. So one of the kind of nice things about Test Cafe, which is a bit different from some of the other browser automation frameworks, is that it will wait for the page to load before kind of failing the test. So you'll see here there's a bit of a loading screen on our VR app that takes a bit of time to go away. And rather than just failing the test because there's nothing there for it to do, it will kind of wait for it to load, which is quite nice. So we don't have to worry about our test kind of failing for no reason. So this will kind of wait now for this loading screen to go before actually trying to run these tests. So we'll then go down and click on the VR button to enter VR. And then our test will start executing these actions. So we're moving the controllers across the screen to pop these bubbles, and then we can take the snapshot to check that the right bubbles have been popped on the screen at the right time. And that's passed there, which is pretty cool. So I started this talk by saying that testing the new web is pretty hard. And then I kind of went through and talked about how we can test it, which kind of sounds like I just contradicted myself for half an hour. So is this actually correct or not? Are things pretty good? Can we test the new web? I think it's kind of a mixed picture. So some of you might have heard of this. This is the testing pyramid. This was devised by a guy called Martin Fowler a few years ago now. And this describes for kind of standard web app, the kind of proportion of different types of tests we should have in our application. So at the bottom of the pyramid, we've got our unit tests. These are the tests that just test individual kind of functions of JavaScript. And these are great because they're really fast to write. They run really fast, but they come with a negative that they're just testing bits of JavaScript. They're not really representing how a user would use your application. Then at the top of the pyramid, we've got our end-to-end tests, and these are great because these test our app the way a user would actually use it in a browser with a real web server and a real database behind it if you're using those things. But obviously the negative of these is they're much slower to write, much slower to run, so we should write a lot less of these. And there's kind of good and bad news with the new web. The good news is that with regards to unit and integration testing, we can still write as many of these as we've always been able to, because kind of no matter how complex the web kind of APIs get, we can still write unit tests on our JavaScript, and we can still write integration tests on our components that we're rendering. But where it gets difficult is the top of the pyramid, where we want to write these really high value tests, where the way we interact with the browsers has changed, and that's where things are pretty difficult still. So I think kind of we've maybe done some of this, but not all of this, and I'd hope in the next few years that we start to make it a little bit easier to write good tests for our kind of complex new web applications. And I think this is kind of what we've got at the moment. I guess it's like a testing mountain or something where the top is obscured by this like cloud of manual testing. I think at the moment, if you really want to make sure that your web apps are working correctly in the new web, you have to do a lot of manual testing. You know, with the 3D app, it was actually really hard to write any kind of test automatically. So you'd have to kind of do a lot of manual testing to make sure that's working. And I guess what I hope is in the next few years that kind of cloud lifts and we can write more and more of these tests automatically rather than having to rely on manual testing to check our kind of new web applications. So kind of in summary, it is definitely difficult to test the new web. A lot of these things took way longer than I like to admit, but it is totally possible if it's really important to you to have confidence that your app works on mobile or peer-to-peer or in 3D or VR. There are ways of kind of getting that confidence with your tests, but they're kind of not as straightforward as maybe testing a simple kind of form-based application. But the really good news is that you can still cover the majority of your applications with unit and integration testing, no matter how complex the kind of web APIs you're using are, which is pretty cool. So yeah, thank you very much. There's a couple of links on the bottom here. One is for the demos I showed, and then the other one is for the GitHub repo with source code for all these tests and the demos as well.
Thank you.